Welcome to the part 2 of this chapter, light. Okay, so welcome students. So as we have studied refraction, then refractive index, now we will get to know about the causes of the refraction. So no wasting time, let's start. What are the causes of refraction? The light travels faster in air but slower in the glass. Okay, now what can you see here? Can we see a beautiful diamond there? A stone, okay? So here what happens, the speed of the light in this diamond is less than half its speed in the air. Okay, so strong refraction and dispersion of the white light through the angle faces of a cut diamond cause it to sparkle with color as it moves. So what happens? Can you see in the lower portion some angles are formed there, isn't it? White light is there. So white light means what? The light ray will come from the air to that piece of the glass, that piece of the diamond. It will fall there. So that is also a transparent medium. So their refraction will be there. Some angles are there. Means as much cutting of that diamond will be, so it will be more costlier only because of this, because it will sparkle more. And as there are strong refraction and dispersion of the white light, so this angle faces of the diamond will cause to sparkle the diamond. Okay. So the refraction of light takes place on going from one media to another because the speed of light is different in the two media, and when light goes from one medium to another, its speed changes, and this change in the speed causes the refraction of the light. Okay, so this is the cause of, mainly the cause of the refraction. So as we have talked about one shape, so next another shape we are going to talk about. Can you guess what it is? It is actually, we are talking about the prism. So let's see. Refraction through a prism. Okay, so this prism, actually what it is? Can we say this prism is what it is? We will say just it is a triangular shape, isn't it? It is a triangle. But how many faces are there actually? Can we have seen what side is there? How many faces are there? Can we ever seen this? No. Isn't it? You see here, there are two triangles are there. Okay, on the both sides, two triangles are there, and obviously there are three rectangles or square, you can say. Okay, four-sided any shape are there, three are there, and two triangles are there. Okay, now what happened? The path of light as it enters a denser medium like glass or water from a rarer medium like air, the incident ray and the ray emerging back into the rare medium are parallel to one another, and this is because the two faces of the slab where the bending takes place are parallel to one another. Okay, one example of the glass object of this kind is a prism, and the base of the prism is an equilateral triangle. Means all sides are equal and the faces of the prism are rectangular. Now the angle between the two plane surfaces is called the angle of the prism, and glass prisms with triangular faces are the most common. Since prisms are made of transparent materials, they refract light incident on them, and when a prism refracts sunlight, something spectacular may happen. Now this is just about a prism, but what happens inside a prism, we will study that also. Okay, so now no wasting time, let's go to our next slide. Angle of deviation in a prism. So what happened? See in the picture first. There is the incident ray. Okay, that incident ray will fall there. Now here also one transparent medium. You can take it as a glass, isn't it? So two transparent medium, air and glass. So incident ray as it fall, what will happen? It will be bent towards the normal. Okay, so it will you can see this little bit bent towards the normal, and the dotted line has gone full outside. Okay, now again that glass from the another refraction happened and we got the emergent ray. Now from emergent ray to that incident ray, which is we have dotted it to the back of the line, okay, there is a displacement. We have studied now displacement. Okay, now from this displacement there is an angle formed there. So that angle is known as the angle of deviation. So the angle by which the incident ray bends to form the emergent ray. Incident ray will bend to form the emergent ray, that is known as the angle of deviation. And here the incident ray of light bends towards the normal as it travels from air to glass, and the emergent ray goes away from the normal as it travels from glass to air. So the bending is same as in the rectangular glass slab, same process, but here this is just a prism. Okay, now while studying anything, we all know that this all came to us, we are learning this all with the help of some great scientists. Okay, now one of our great scientists has taken out another very interesting thing in prism only, but what it is, okay, we will get to know now. I will not keep you longer. Let's start with the next slide. The splitting of white light by a prism, that is known as a spectrum. Now let's see what is it. A white light, or can say a sunlight, just a sunlight users think, is composed of various colors. We don't see the sunlight, it is just a white light. Okay, but there we know there are a band of 7 colors are there, as we see the rainbow. Okay, rainbow also we will study. Now whatever Newton came in the year 1665 to discover that white light consists of some 7 colors. But how he has discovered this? With the help of prism. Let's see. It is found that if the beam of the white light is passed through a glass prism, the white light splits to form a band of 7 colors. So what happens here actually? Here what happens, when the incident ray, means the white light will fall there, so there will be refracted ray. In the refraction in the prism, what happened, as there are 2 triangles are there and all the sides rectangular faces are there. So there, this white light in the inside the prism, it will split up into 7 colors, and that 7 colors will come as an emergent ray outside. Okay, I think you can see the diagram there. So the band of these 7 colors formed on a screen when it's passed through a beam of white light is passed through the glass prism is called the spectrum of the white light. This is known as the spectrum of the white light. And these 7 colors are what? VIBGYOR, we know. V for violet, I for indigo, B for blue, G for green, Y for yellow, O for orange, R for red. VIBGYOR. So this idea has taken by who? Newton. Newton has taken out this idea that white light consists of 7 colors with the help of the glass prism. Okay. Now, but again he wanted to prove something else. Let's see what. He had taken out Newton's color disc. Now, with this experiment, he said that these 7 colors will produce white light again. But how? Sorry. What he has done? He has drawn the 7 colors in a color disc. Okay? In a cardboard, he has divided into 7 colors and he had drawn it. And then, with a very high speed, that disc is rotated. Very high speed. Then what we had found there? We have found a white light there. As a disc will be rotated very fast, it will appear white in color. So he has proved this, that from a white light, by passing through a glass prism, if we get 7 colors, means the spectrum of the white light, then from that 7 colors, we can get again back the white light. So with the help of Newton's color disc, Newton has proved this. Okay. Now we are going to study some practical concept. What are those? Let's see. Why do we use red color light for the danger signal? Okay. Only why red color is used, not other colors. Not why blue, orange, yellow. Why not? only red colors is used. Have you seen the red colors in the emergent ray? It was in the top position and the violet was on the lower position. But we always say VIP 0, no? Not from R. We start from violet always. Now, this red color deviation is minimum, while the violet color light has maximum. But the wavelength of red light is maximum and it has a probability, or the reading the light to the observer is the most. So this is the reason the red light is used in the danger signals. So we will see as the deviation is less but the wavelength is more. So we will see the red light more than the violet light. Okay, so red color light is used as a danger signal. Now, one more experiment we are going to study. Let's see. Recombination of the colors of white light by second prism. Now we will take here two prism. One will be in the proper position, okay, and another will be upside down. What we will do here, the emergent ray means the spectrum of light, again we will connect with another prism, will pass through that prism and we will get a white light again. See in the diagram. What happened here? The order of colors are same, isn't it? All the order of colors are same. While the 7 colors of the rainbow that are violet, indigo, blue, green, yellow, orange and red. Now we can combine the colors splitted by glass prism by placing another glass prism there. First white line, then dispersion happened, means emergent ray came out. That emergent ray again gone through another glass prism and with that again it is recombined. The white light is recombined there. Okay, so here you can just study here, students, but practically in the higher classes when you will do this experiment, it will be very easier for you to understand. Okay, so now we are going to study about what? Colors. What colors? Have you played this game? Now we are very excited to see a rainbow, isn't it? But rainbow comes at what time? Do you know? Do you know? Okay, so let's study about rainbow now. Okay, the formation of rainbow. So rainbow normally we don't see, but after the rains in the sky we can see sometimes a rainbow. But rainbow will be always opposite to the sunlight. Always remember that. Okay, what happens after the rain? That in that time only we can see in the sky the rainbow. Why? So after rain, what happens? Some water droplets remain in the atmosphere where the dispersion of light takes place, and when the sunlight passes through the water drops, the appearance of rainbow in the sky happens. That water droplet is what? Nothing but the water. And water is what? Nothing but a transparent medium. So in that single water droplets also, what happened? Dispersions happen. Okay. So we can see the spectrum of light there also. The refraction will be there also because water is a medium. Okay. So from air to the water droplet, if you see the dispersion there, so many water droplets may be there after the rain in the atmosphere. We feel cold, no, slightly cold after the rain, the shower of the rain. We feel slightly cold, means some moisture is there in the atmosphere. So from there, what we can see the rainbow. As soon as the sunlight the clouds will disappear, the sunlight will fall on the water droplets, means opposite to the sun, you will see the rainbow happening on the sky only for a small minute of time, because after the sunlight comes, that water droplets will slowly disappear and rainbow will also disappear. So till here I'm stopping this video. Hope you have liked it. You have liked it, no? Okay. So now we'll start about curved or spherical mirror on the part 3 of this chapter, and that one will be the last part of this chapter. So till then, take care. Bye-bye.